Hey guys, I'm back. I'll be creating a series of videos discussing the topics in Calculus 1. Don't forget to follow my page to be updated on every topic that I'll be posting. Kindly share this video to your children, friends, and brothers and sisters to help them learn calculus. So sit tight and enjoy my engineering códigos, the path of becoming an engineer. Right, so for today's topic, we will be talking about the infinite limits. So this topic is a continuation of our series topic about limits. So what are we waiting for? Let's go ahead and let's learn the basic concept of infinite limits. So first, let us define a theory about infinite limits. So we say that the limit of the function f of x as x approaches to a is equal to infinity if we can make the function f of x arbitrarily large for all x sufficiently close to x is equal to a from both sides, without actually letting x equals a. And we say that the limit of the function f of x as x approaches to a is equal to the negative infinity if we can make the function f of x arbitrarily large and negative for all x sufficiently close to x equals a from both sides, and without actually letting x is equal to a. So, for better understanding regarding this theory, it's better for us to go directly to an example. We have here an example. We are going to evaluate and find the normal limit of the function, limit of the function 1 over x as x approaches to 0. Okay, so looking at the given function, as you can see, we cannot simply plug 0 into the equation, right? So what will happen is it will be undefined. So now think about it. Can we play with algebra so that we can evaluate this limit? I think that would be also difficult, right? So first, regarding the question, we are going to evaluate the function and find the normal limit. So from our previous discussion, the question is, does the normal limit exist? Right? But before we try to solve this problem, it is important for us to apply first our previous knowledge, the discussion about the one-sided limit. If you remember that the normal limit only exists if the left-hand side limit and the right-hand side limit are equals, right? So the best step to calculate or to evaluate this problem is to start with the evaluation of the one-sided limit. So let's start with the right-hand side limit. So let's define or let us calculate this limit as x approaches to 0. So that means we are going to divide 1 by a positive number that approaches to 0. So take note, as we move closer and closer to 0, that means that the number becomes a very small number, right? And then what do you think will happen if we are going to divide a whole number by a very small number? What do you think will be the result? Exactly. The result will be a very large positive number, right? And take note, from our previous discussion about limits, a very large positive number corresponds to exactly infinity. So therefore, the limit, or the right-hand side limit of the function 1 over x as x approaches to 0 is simply equals to infinity. Perfect. Now, let's evaluate the limit on the left-hand side. So in this case, that means that we are going to evaluate the limit from the left-hand side of 0. That means the value of our x is a very small negative number, right? So, what do you think will happen if we are going to divide a positive number by a negative number? Exactly. The result is always negative. And one more thing. The same as the right-hand side limit, if we are going to divide a whole positive number by a very small negative number, the result will be a very large negative number. And a very large negative number corresponds to a negative infinity. Perfect. So therefore, the limit of the function, the left-hand side limit of the function 1 over x as x approaches to 0 is actually negative infinity. Right? Excellent. Now, going back to the main problem, we are going to evaluate the limit and find the normal limit. So with this one class, so if you try to think, does the normal limit exist? Of course not. As you can see, our limit on the right-hand side is a positive infinite and the left-hand side is a negative infinite. These two numbers are definitely not the same. So therefore, the limit of this function, this very simple function, the normal limit actually does not exist. Okay? So that's how nice and easy this problem is. Okay, and I hope at this moment you already appreciate the importance of the one-sided limit, our previous discussion. Let's have another example that will showcase more about the concept of infinite limits combined with the left-hand side, the one-sided limit. So how about this one? This problem is very similar, but the denominator is now raised to the power of 2. So to evaluate this limit, we will use the same concept. We'll evaluate the right-hand side and also the left-hand side limit of the function. So starting at the right-hand side, so if we are going to divide, first, what do you think will happen to a very small number raised to the power of 2? Exactly, the result will still be a very small number. It will become an even smaller number, right? So now, if we divide 1 by a very, very small number, then that means that the result is also infinity. Excellent. Next, let's evaluate the left-hand side limit. So, what do you think will happen to a very small negative number multiplied by itself, which is a very small negative number? Exactly. The result will be a very small positive number. So in this case, we are going to have 1 divided by a very small positive number, then the result is a positive infinity. So in this case, if we go back to our main objective, the limit of the function 1 over x squared, the normal limit as x approaches to 0, is also equal to infinity. Nice and easy. Let's have some facts about these infinite limits. So what are the facts that we can formulate? So we have the following. So let's say we are dealing with two functions, and then the limit of the function f of x as x approaches to c is equal to infinity, and the limit of the function g of x as x approaches to c is equal to L. Take note, L is a constant, okay? So we have the first one fact about this one. The limit of the function f of x plus or minus the function g of x as x approaches to c is equal to infinity. Yes, of course. If we are going to add or subtract a constant number to an infinite number, the result will always be infinite. That's why this number one, or this one fact, is actually true. Next one. If L is greater than 0, then the limit of the function f of x times g of x as x approaches to c is also equal to infinity. Well, this is very obvious. If we are going to multiply infinite by a certain number greater than 1, greater than 0, it will always be infinite, right? I think there's no question regarding that. The third facts about infinite limits. So let's say that the value of L is less than 0. Then the limit of the function f of x times g of x as x approaches to c is equal to the negative infinity. Well, in this case, when we say L is less than 0, that means the value of L is negative, or it's a negative number. So what do you think will happen to a positive number multiplied by a negative number? Exactly, it will also be a negative number. So that means if we're going to multiply a positive infinity by a negative value, that positive infinity will become a negative infinity. So this fact is also acceptable. Last facts about infinite limits. The limit of the function g of x divided by the function f of x as x approaches to c is equal to 0. Well, yes, if we are going to divide a constant number by a very large number, so that value will approach to 0, and that means its limit will be 0. Okay, so I think that's all for today, and I hope you learned something regarding our short discussion about infinite limits. So I hope to see you again on our next topic, and in Generalcast, just signing off. Bye-bye!